Okay, so I have decided to try and do a video on just the workflow I go through post a capture session. This particular object, NGC 2467, not an ideal target. Kind of small for the imaging rig that I'm using. The full moon is still up, so I've gone narrowband, which probably hasn't helped, and is just a sort of a target of opportunity. So I don't know how well this is going to go. Look, I don't think this is probably going to be a keeper, but I'm going to give it a go and run through the process. In particular, I tried to run this. We ended up running out of time, didn't get quite as many subs as I wanted to in HA. Now the weather's all clouded out and stormy, so I don't really have an opportunity to get some more. This is more going to be a trial to see if I can get anything out of it. So I did a capture, ended up running S2, O3, and HA, so I've got 27 subs each of 5 minutes of S2 and O3, and looks like I only got about 8 decent HA subs. Had a couple of subs where I've already gone through and had a look at them, and there are some problems with them. It was late in the imaging session, and it was getting very low. So this one's like really the guiding's gone off. Primarily, I think the guider was actually heading into the trees, so it was losing track of where it was going. So these last few just didn't really work. They got mangled by the guiding, so they aren't any good. So I've already eliminated those. So what the process is we fire up DeepSkyStacker. This is a process I go through. I will, because all the subs are at 5 minutes at minus 20 degrees. I've already got some darks for that. I've already processed these darks and made a master dark, so I'm going to put that in the main group as a dark. I need to put bias frames in there again. Done a set of bias at minus 20 as well, so put those in the main group as bias. They're the only calibration frames that I'm going to use across the board. I'm going to use flats per group. So in group 1 we're going to run this as SOH, so I'm going to just keep that order as I go. So I might as well just put the flats in first. So we'll start with the S in group 1 as a flat. Then go O in group 2. And HA in group 3. So by way of explanation of what each of those types of calibration frames do, a dark is an image taken at the same duration as the lights. So this is a 5-minute image of nothing. Literally, I have a dark filter which is opaque, pointing and covered up the telescope. So it looks completely black, but when you stretch this and have a look at what it looks like stretched, you can see defects as a result of the way the chip works. So you can see over on this side there is some brightness that's probably coming from amp glow or some other part of just inherently what's happening in the chip when it's a baseline of no signal. So that's what you're getting, and what we're trying to use is this to eliminate that background sort of signal from the images. When you're looking for bias frames, it's a similar concept in that you take the shortest possible exposure the camera can do as kind of like a noise floor, so that this, again stretched, will give you a baseline of what an image has as inherent noise just from the basically reading out from the chip. So you subtract that, gets subtracted as well. Okay, so that's what those calibrations are. Now, when you're looking at flats, flats is an image that has been taken at ideally something that is going to give you about 50% of the capacity of the sensor with a flat white frame. So just literally this is pointing at the sky with like a white t-shirt over the front to just get an even illumination. What we're trying to do is remove sort of inherent defects in the image train in whatever way. If there's dust on the filter or some other, some sort of thing on the front of the chip window or something like that, and we're aiming here to see if there's anything that becomes visible. So this one is the S. It doesn't seem to have anything super obvious. Let's have a look. So you can see the difference between the two filters. We have slightly different properties to them. It's a bit tough to see, but they are a little bit different. We've got the flats in there now, so what we're going to do is load up the actual images. So we started with the S's, so we're going to dump all of these in to the first group. They're going to be light frames, then the O's, and then the H's. Right, so just get a feel for what these look like. So yeah, you can see these ones later in the night had more issues with some of the guiding. So don't know if we're going to be able to get some of these out of the way. So some of these were, so earlier in the evening we were getting dark frames. So really, in the ideal world, if the weather was good, I'd be shooting all the HA frames again from earlier in the night. This was towards the end of the night. These were happening sort of 4 or 5 a.m. rather than something sort of more around 11 p.m., which was way closer to the meridian, which was easier to image. So they're the HAs, not brilliant. The O3s, not a lot of, there's some detail in there, but not sure what they're going to look like, but they're okay. And the sulfur images, there's not a lot to see in there. Again, looks like we've got some pretty ordinary guiding happening at some point there, quite elongated. So I'm not sure if I'm going to keep any of this, to be honest. We might have to throw it all away, but let's see what happens. All right, so now that we have everything loaded up, I'm going to probably go for the HA frames. Have a easiest to look at in terms of centering of the target and stuff. I'm going to set that as a reference frame to use as the framing, and all the other images will be mapped to it. So that one looks reasonably centered. Probably, actually that one looks a little bit better, so we'll use that. So we mark that one as a reference frame, and then I'm just going to save the file list away. So in all right, so that just saves the file list, and so we're going to make it. We know I know all of them have been selected, all the tick boxes. So we will go and register them. So we're going to click on register already registered pictures. I don't think that's an issue. So we're going to kick this off. Now this could run for quite some time. So what it's doing is using that reference frame as a master. It's working out where all the stars are and their orientation, and effectively knowing how all of these are going to map to each other so they stack properly on top of each other. So this has got another 4 minutes to go, so we'll just let that run through and we'll pick it up when this is finished. All right, so all of those are registered. So when we have a look at what that does, the software scores the frame, I guess. So the higher the number, theoretically, the better the quality, and the lower the number, the worse they are. So you can see the background is not as nice on that as it is, for example, on that one. You can also see the counts of stars. Now, if these are vastly off compared to each other in the same types of frames, that probably indicates there's some level of problem. These are all sort of a bit variable, but like some of these frames are a little bit better than others. They were earlier in the night, sort of maybe degrade a little bit over the course of time. Now these scores are way different, but it's based on the type of filter, so you're getting different kinds of results because the filters are different. It's about the consistency between them. So, but there are no huge outliers here, that in terms of like particularly low numbers or anything that make you worry about it. These are all relatively good over here. Let's have a look at HA. So you can see here, and this is true of how the night went. So obviously there was not too bad there, but you can see here we've gone from, so these numbers are getting vastly different. not sure what we would be saying here. I mean, I don't like the look of much of this, and we're probably not going to keep this, but you can see there's quite a variation here, and you can see the sky background is getting way higher. So I don't know if cloud moved in. I mean, I was sleeping when this was happening, so I can't really tell, but it's not the best. So if I had seen during this process some really horrible things, and if I actually thought that this was going to come out better, and I mean, I feel like this isn't going to work very well, I would go through here, find images that I didn't want. I would probably potentially look at them all in more detail and eliminate any that were more problematic, and remove them so that we don't stack them. But now it's more about just going through the process. So at this point, we would stack them. Now, what I'm going to do is produce 3 individual stacks, one for each of the filters. So what I'm going to do is I'm going to uncheck everything, so none of them have any checkboxes. I will check the darks, then I will do the first set. Check those. So we're going to do all the sulfur ones. So the stacking doesn't actually take that long compared to everything else. So we have 27 frames of 5 minutes each. So that gives us 2 hours and 15 minutes in that set. So let's just go. This only should take about a minute or so. And you can see these offset numbers are basically compared to the reference frame how far out it is. So they've moved over the course of the night, as you can see when I was flicking through the images, and the angle as well. So I think most of these photos were actually taken after the meridian, so you don't see meridian flip where this angle would be 180 degrees. But you can see there's a variance here, which is all taken into effect, and what you'll see with that is when we actually stack them, that you'll have a sort of a pattern where you can see there's less and less of the image over the course of maybe, I don't know which direction it was, but sort of this side here will have less data, and that'll become more obvious when we look at it. Let's have a look. Just getting through this. Okay, so that one's come out not too bad. All right, so I'll save that picture as so the way I do it is I put so it's S and the number of minutes, so it's 2 hours and 15 minutes, so that's 135 minutes. Okay, so now we're going to select all of those and uncheck them. We're still leaving our calibration frames there, and now we're going to go in group 2, select all of those, check them, and stack them. Again, these this is our 03, same duration, so it's going to let that go. All right, let's see, that's come out. You can see around this edge, because of the way the images were being stacked, that we've lost this edge around here compared to the others. So anyway, let's save the picture. This is going to be 135. And uncheck those, and then We'll check these and stack them. So we've only got the 8 images at 5 minutes each, so that's only 40 minutes. %. This is not going to be something that I'm going to want to use, because all these stars are all elongated, and it's just not really going to work. So, I mean, we can see up in the top left corner there, the shape zoomed in. I mean, we've got eggs, so I'm not surprised. This is way down on the horizon, and the guiding was off. So, all right. So now that's our 3 images. So I will save the file list. So if I come back and add some more HA and get rid of these ones, I might have another go at it. So we have got those 3 images. So let's fire up Photoshop and drag these in. All right. So you can see I'll order them kind of in the order that we will have RGB. So that's the first one. The second one, you can see these are way out, and we've got all of this edge when they've been aligned that we're going to have to crop out anyway, and our H as well. Okay, so what I normally do at this point is I make another one. Doesn't matter, I just copy one of these as a baseline. And we're going to open this one up as well, and we'll use this one as the basis for where we're going to save all the work. So we'll use this one. We're going to turn that into an RGB image. Then we will go to channels. You can see it will have copied that same channel onto all of them. They're all identical. So we'll start with our red. So I'm going to go grab that and copy it in to the red channel. Actually, I'm going to change this so it's going to be SHO instead. So that should give us a bit better of a look at it. So S is still correct in red. So we'll grab H for green instead, and O for blue in here. Okay. Yeah, okay, so you can see there's a lot more green through here. It's all gone a little bit warped around here. You can see where the difference between the frame layouts means we're going to have to cut off all of this bit. So at this bit, I would start. So I'm just going to ignore all the flaws in it because we're just going through a process now. Is I would start working on calibrating these out. So the first thing I would do is I'm going to just see if we can stretch this a little. So start with looking at these levels. So pull out some of the range here and go curves and stretch this. Levels again. Alright, so really the alignment that we have on here should be a bit better, but I'm just going to stretch it a bit more first. And I'm just going to run auto and see if we can get these three to line up over the top of each other. No, not really. Alright, well, I'm going to try the individual channels. So let's have a look at red. Red, I think we're doing okay. It's probably going to upset the mix a bit, but let's bring all the greens back down here. And the blue, bring the baseline of the blue here. Alright. So I think what we're seeing here is definitely all this HA, which is the green, has just, you know, completely, you know, we've just got way too much of this. It's not salvageable. We're going to hack it a bit. We're going to use a gradient tool from Pro Digital Software, AstroFlat. So this should, I mean, this is the original, and this flattens the gradient and normalizes. I mean, like, it does a spectacular job just on the defaults, leveling that out. And then we can clip it a little more and see if we can stretch anything else out of it. It's getting pretty noisy now, so I'm gonna just see if we can clip a tiny bit more out of here. All right, I think that'll do. So because I'm not really gonna be too fussed with this, I'm gonna save it, but I'm not gonna, I would normally version this and make another version of it before I did too much more to it. At this point, this is from Pro Digital Software. These are a whole bunch of actions that are astronomical functions that we would use in here. There's quite a few of these that I would use. I mean, this is a very noisy image. I would run space noise reduction to try and get some of this out of the background. Deep space noise reduction to sort of just get a bit more of that going. I mean, let's just do them. Look, there's a lot of problems with this one in general. I would probably, let's do enhance DSO and reduce stars, that one. Alright, so you can see the difference between before and after that action. So look, normally this has much nicer effect on it. We've just got really crappy images in the background, so we're not going to do much with this now. And given that this is not recoverable in any shape or form, I'm not going to try and do much more else to it, other than I'm going to just apply false color mapping, see what that does to get a bit of vibe. Let's just run that. This is an action I've made available on GitHub. It's just a bunch of, it's a macro effectively of steps that just change the color. Yeah, it's honestly, it's improved it, got rid of a bit of that hazy green. Now, the last step I always do at the very end, so I don't do anything up until this point in terms of cropping, because you want everything to be laid over exactly the same. I would normally potentially at this point also get the HA. I will just do a really quick stretch on this one. Yeah, I'm not gonna be too fussy with this because so what we're trying to do is bring out some of that nebulosity there. All right. So we're getting a lot more of this through here. And chopping off the black. Let's run the gradient exterminator off it. Yeah, seeing how well that does. Alright, so I'm going to highlight all of that, copy it, and then we'll use this as a luminance layer. In fact, what I'm going to do is I'm going to flatten all of this just to make it just a little bit more obvious. And I'm going to paste that, and then I'm going to use that as a luminance layer. To highlight and bring out more detail. Yeah, probably around about there. So at this point I would then just crop down, get all of this stuff out of the corners, try and lay this out a little bit better just in terms of centralizing it. Losing a lot, but I'm happy with that because it's hiding some of the grossness. And crop it. So that's the general process that I would go through. This whole thing was a write-off in terms of what I got out of it, so not going to do anything with that, but that's the general process that I would go through to image. In hindsight, probably would have been better to show you one of the ones that I had done that didn't turn out horrific. So let's just have a look. This is the one from yesterday that had followed through the same process. So this one is a lot more data, a lot better data, but I followed basically the same steps. Obviously it's a different target, it's a much more colorful target in terms of the data available, but that's what you would need to do to get an image of like this. Hopefully that was give you a fair feel for the process that I go through.